When you look at cloud networking, do you ever just think, gosh, there has to be a simpler way, like a more secure way to connect all your stuff in the cloud, especially when things can get, well, complicated pretty fast.
Oh, absolutely. It's a common hurdle.
So today we're diving deep into what really forms the foundation of Azure networking. We're talking virtual networks, VNets, subnets, and VNet peering.
That's right. And this deep dive, think of it as your shortcut, really. A way to get your head around how these core pieces work together to build communication that's secure, that scales, and importantly, is reliable right there in Microsoft Azure.
Okay.
Our mission today, let's unpack what they do, the actual problems they solve for you, and, the key things you need to know to use them well in your own cloud designs.
All right, let's get into it then. The heart of it all seems to be the virtual network, the VNet. So if I'm starting out building my cloud setup, what's the main idea I need to grasp about VNets?
Okay, so a VNet. Picture it as your own private network space in Azure. It's logically isolated, completely separate from other Azure customers.
Like a walled garden.
Exactly like that. It's where all your Azure resources, think VMs, databases, maybe app services, can talk to each other securely. It's designed to feel a bit like your traditional on-prem network, but, with all the cloud benefits like agility and massive scale.
And that isolation is key, I imagine.
Oh, absolutely crucial. For basic security, yes, but also for meeting compliance rules, things like HIPAA or GDPR. It's foundational.
Okay, so the VNet is my private playground. Now, you mentioned subnets. If the VNet is the whole estate, what exactly are subnets doing inside it?
Right, so subnets are they're like putting up internal walls or fences within your VNet estate. They let you break down your network into smaller, more manageable chunks.
And why is that powerful?
It's all about control, segmentation. It means you can apply really specific rules, security policies to different areas. This is where network security groups or NSGs come in.
Ah, NSGs. Heard a lot about those.
Yeah, they act like mini firewalls dictating exactly what traffic gets in or out of a subnet. So, for example, you could have one subnet for your web servers that face the internet and a totally separate, more locked down subnet for your back-end databases.
Ah, okay. Least privilege, but for the network.
Precisely. It helps stop things moving sideways if, say, one part gets compromised.
Makes sense. So you've got these isolated VNets, maybe segmented with subnets, but what if you need different VNets to talk to each other? You don't want to send that traffic out over the public internet, right?
No, definitely not if you can avoid it. And that's exactly what VNet peering is for. It lets you connect two Azure VNets together seamlessly.
Seamlessly how?
It uses the Azure Backbone network, so it creates a private, low-latency connection between them. It doesn't matter if they're in the same Azure region or different ones across the globe.
Oh, even across regions.
Yep. Global VNet peering connects VNets in different regions. So your resources in, say, East US can talk to resources in West Europe as if they were practically neighbors. It means much lower latency, and you avoid those data egress charges you'd get going over the public internet.
That sounds huge for distributed applications or disaster recovery setups.
It's essential. Really, it's the backbone for building those modern geo-distributed systems effectively.
So, stepping back a bit, VNets for isolation, subnets for segmentation and fine-grained rules with NSGs, and peering for connecting VNets privately. What are the big overarching problems these solve together?
Well, you nailed the core functions. Together, they tackle some major cloud networking headaches, like overly complex setups, relying too much on the public internet, and just general network sprawl.
How so?
The VNet gives you that fundamental isolation, that private IP space. Subnets bring order to the chaos, letting you organize and apply those NSGs for tight security. And peering, well, it takes the public internet out of the equation for VNet to VNet traffic, giving you speed and privacy.
So simpler management, better security, more scalability.
Exactly. And it also helps tick those compliance boxes, which is often a huge driver.
Okay, this is clicking into place. Now, for someone actually designing this stuff, building out their Azure environment, what are some key best practices? Things they absolutely should keep in mind.
Number one, absolutely critical. Plan your IP address spaces. Make sure your VNets have non-overlapping IP ranges.
Why is that so important?
Because if they overlap, you'll run into massive problems later if you want to peer them, or connect back to your on-premises network using something like a VPN gateway or express route. It becomes a routing nightmare.
Okay, non-overlapping IPs. Got it. What else?
Always use subnets to isolate workloads. Don't just dump everything into one big subnet in your VNet. And apply NSGs, diligently think about the traffic flow you actually need, and deny everything else.
So don't just rely on the VNet boundary alone.
Right. I've seen folks think the VNet is enough, but those subnet divisions and NSGs, that's where the real granular defense comes in. Also, use role-based access control RBAC to manage who can change your network settings.
Good point. Securing the management plane.
Definitely. And maybe automate deployments with ARM templates or Bicep. It helps avoid manual errors, which are pretty common with things like NSGs or route tables. Oh, and test. Test your rules in a staging environment before going live.
That sounds like solid advice born from experience. Okay, so let's quickly recap. VNets give us that private space. Subnets let us divide and conquer with specific rules using NSGs. And peering connects these VNets efficiently and privately. Together, they let us build everything from simple apps to really complex systems, moving beyond old on-prem limitations.
Precisely. The key takeaways. Plan your IPs carefully, no overlaps, use subnets wisely for isolation, lock things down with NSGs, and control access with RBAC. Get these right, and you're building for performance, compliance, and much easier management.
So thinking about all this, the isolation, the segmentation, the secure connections, it makes you wonder. Think about your own digital life, maybe your work. What's one area where you could imagine applying this kind of granular secure control to simplify complexity? Maybe somewhere you haven't even thought of applying that kind of thinking before. Something to chew on.